Section 5.4 Common and Natural Logarithmic Functions. Common logs can be written as log base 10 of x equals log x. It has a base of 10, but it's unnecessary to write the 10 because the base of 10 is assumed. We're going to do a couple examples without the calculator. We're going to find each value. So for example A, log 100,000. You're going to do 10 to the x power equals 100,000, and since these are common logs, we ask 10 to what power equals that number. Since the number is a power of 10, we can count the zeros. X would equal 5. For example B, it's going to be log 10. 10 to the x power equals 10. X would equal 1 because there's only one zero. For example C, we're going to be doing log to the cubic root of 100. We're going to start off by taking 10 to the x power equals 100 to the 1/3 power. Then it's going to be 10 to the x power equals 10 squared to the 1/3 power because the square root of 100 is 10. 10 to the x equals 10 to the 2/3, and the two tens would cancel each other out, equaling 2/3. For example D, we are going to be doing the log of -7. We're going to start it off by doing 10 to the x power equals -7, but it would not exist because you can't take the log of a negative number. Log base b a equals x is an equivalent statement with b to the x equals a. We are now going to do examples of equivalent statements. Log x equals 5, so 10 to the 5th power equals x. X will equal 100,000 because, like I said earlier in the video, all you have to do is count the zeros. For example B is going to be 10 to the x equals 52. So log base 10 of x, 52 will equal x. And then x will equal log of 52, and you will plug this into your calculator and you'll get x equals around 1.72. We are going to now do natural logs, which are expressed as e, or it can be abbreviated as ln. Log base e x equals ln x. Now here are some examples of natural logarithms. So for example A, we're going to do ln 1.3, and all you have to do is plug it into the calculator and you should get 0.262. For example, second example, we're going to do ln -12. And when you plug it in, it won't work because you can't do a negative number, so it doesn't exist. For our third example, it's going to be ln 1, and when you plug it in, you should get 0. Now we're going to do equivalent statements of natural logarithms. Example A, ln x equals 2. So you're going to set it e to the 2nd power equals x. X should equal 7.3892. For example B, it's going to be e to the x power equals 8. X will equal log base e of 8. X will equal ln 8. You plug it into your calculator and you should get x equals 2.079. And that will conclude this video.